Hello students. So today we are going to start the second exercise from this chapter. So let us start with number 1. First question, state whether true or false. That means here you have to state whether it is true or false, and you also have to give reason, justify why it is true or why it is false. Okay. So question number 1, every irrational number is a real number. First of all, you recall what was the definition of real number. Real number is a collection of rational number as well as irrational number. Now they are saying all the irrational numbers, root 2, root 3, all of them fall in the category of real number. All of them are real numbers, definitely, because real number is a collection of rational and irrational numbers. So it is true. True because real number is a collection of rational and irrational numbers. All right. Next question. Every point on the number line is in the form of root over m, where m is a natural number. Now you see in a number line, we have positive numbers, we have negative numbers, we also have zero. Okay. Yes, we can express as the square root. Positive and numbers and zero we can express as the square root of any number, right? But can we express a negative number? Suppose we have root 2. Can we express it as a square root of any other number? Can I represent minus 2 as a square root of any other number? No. So that's why it is not possible to represent all the numbers. They are saying every point. How is this possible? In a number line, negative numbers cannot be represented in the form of square root, right? So this is false. False because negative numbers cannot be expressed as the square root of any number. Okay. Next, number 3. Every real number is an irrational number. Now let us recall again. Real number, collection of rational and irrational. But every real number, can it be irrational only? No, because in real rational number also false, na? So we cannot say that all real numbers are only irrational, because rational numbers are also irrational, also real, na? So it is false. False because real numbers can be rational. So we have solved question number 1. Now let us move to the next question. Question number 2. Are the square root of all positive numbers irrational? If not, give an example of square root of a number that is rational. Okay. Now, irrational numbers example I have shown you, like root over 2, root over 3. And the reasons also I have told you, because when you will find the square root of this number by long division, then what you will get? You will get non-terminating decimals, and they are non-recurring also. So they are irrational numbers. Okay. Yes. But they are saying are the square root of all positive numbers. All they are saying. Root 2, root 3, okay. But if I take root 4, if I take 4 here, 4 I can write 2 square, then I'll get 2. Similarly, if I take root over 1, then square root of 1 is what? 1. If I take root over 9, 9 is 3 square, so I will get 3. So we can see that 2, 1, 3, are they irrational? They are the rational numbers. They are rational numbers, right? So are the square root of all positive numbers irrational? No. right? Now why we have to explain it with an example. Okay, no, because root over 4 is 2 and or root over 9 is 3, which are rational numbers. Okay, or you can just give one example, because root over 4 is 2, which is a rational number, which is a rational number. I hope it is clear. So next, question number 3. So question number 3, show that root over 5 can be represented on the number line. Now root over 5 is an irrational number, so we have to represent it on a number line. Okay, so before we do this, we have to recall one small thing, that is a Pythagoras theorem. I hope you remember. In a right angle triangle, what was Pythagoras theorem about? If this h is the hypotenuse and b is the base and p is the perpendicular, we studied that the square of the hypotenuse is equal to the sum of the square of the perpendicular and the base, or the square of the hypotenuse is equal to the sum of the square of the other two sides, right? The same thing we will use it. Okay, but here, while using the right angle triangle to represent root over 5, the base how many units we need to take, the perpendicular how many units we need to take, that one we have to see or consider, right? Suppose this is a right angle triangle. If I take the base as 2 units, okay, if I take the perpendicular as 1 unit, now if I find the hypotenuse, then according to Pythagoras theorem, hypotenuse square is equal to 2 square plus 1 square. 2 square is 4, 1 square is 1, 5. Now if I send the square that side, it will be root over 5, right? So when I will get root over 5, when I will take the basis 2 units and the perpendicular as 1 unit. This triangle I have to somehow represent on the number line. This right angle triangle, I have to bring it on the number line, right? So let us do it. So first of all, let us draw a number line. 0. But remember one thing, while you are plotting the numbers, or while you are writing the numbers on a number line, they should be at equal distance. Since I don't have a scale, because I don't have a big scale to do it on a whiteboard, so I'm doing it with my hand. But when you write the numbers, write them at equal distances. Suppose between 0 and 1, if you are taking 1 centimeter, then between 1 and 2 also, 2 and 3 also, you take 1 centimeter, 1 centimeter. If you are taking 2 centimeter, then 2 centimeter, 2 centimeter. Okay, so here I'm plotting the numbers at equal distances. Here also -1, -2. Okay, now I have to represent -5. So from 0 to 1 it is 1 unit, 1 to 2 it is again 1 unit. So from 0 to 2 it is 2 units, right? But I have to consider it as a line segment. So let us take here this as point A and this one as point B. Okay, now to draw a right angle triangle, we need a perpendicular, right? So I will draw a perpendicular through B, that is BC. And remember, this BC should be 1 unit. That means if you are taking here 1 centimeter, this should also be 1 centimeter. Okay, so this will be 1 unit. Okay, now you join A and C. Okay. Now, before solving it, we have to write what we took. Okay. We have taken AB equal to 2 units and drawn a perpendicular BC such that BC equal to 1 unit. We have joined A and C. Okay, after that, we have got a right angle triangle, right? Now, if I apply Pythagoras theorem in this right angle triangle, in right angled triangle ABC, the square of the hypotenuse is equal to the sum of the square of the other two sides. So, AC square, I don't have any number, so I'll write it AC square only. AB square is 2 units, so 2 square, and BC square is 1 unit, so 1 square. 2 square is 4, 1 square is 1, so I got 5. Now this square, if I send the other side, I will get root over 5, right? So root over 5 units I got. So AC represents root over 5 units. Okay, now what we have to do, we got AC equal to root over 5 unit, but we have to represent it on the number line, right? This is above, this is not on the number line, so we have to represent it. So what we'll do, since I don't have a compass, but you have to use compass here, you will place the center of the compass at the point A, and then you will take the radius as AC, and taking AC as radius, you draw an arc. You draw an arc and wherever the arc has intersected on the number line, you name it a point. Suppose I have named it as D. This OD will represent root over 5 on the number line. This OD will represent root over 5 units on the number line. So whatever we have done, that one we'll write here. Now, taking A as center and AC equal to root over 5 units as radius, we have drawn an arc which intersects the number line at B. Therefore, AB equals to root over 5 units. Okay, so now we have represented this root over 5 on the number line. I hope it is clear. If you have any doubts, you can ask in the comments. Okay, thank you.